the bizarre, the unusual, the unexpected. That's what they found from Mercury on out throughout the solar system. You got to admit they had a nice idea to start with, assuming nothing ever happened, because if you started out assuming all kind of weird things, you'd have a lot of trouble trying to hone in on something. So they assumed that nothing ever happened in the solar system after it was formed X billion years ago. Unfortunately, the data do not support that idea. Pretty much everything they've run into after 1950, when that theory was the main accepted theory, nearly everything they found winds up to be a surprise. They thought Mercury was just going to be a little larger than our moon, and it turned out it's not even close to what they expected. Also, it should have cooled down after 4.5 billion years, but it didn't. And so now they're wondering, gee, why is the center molten, and what other things does that mean? Of course, there was even more oddities. It had a magnetic field. Don mentioned the magnetic field of Mercury earlier, and although it is extremely small, it was completely unexpected. In addition, just a little over a week ago, in space.com, they said, a baffling new mystery has turned up on Mercury, a pattern of giant cliffs and ridges on planet's surface that defies any explanation that scientists have currently been able to offer. Of course, Venus has always been a little strange, but again in the 1950s, and I reference everything to 1950 because that's the time that the first thoughts about maybe everything was not as stable as we thought started coming out, and the astronomers and geologists immediately said, but it's all nice and smooth and there's no catastrophes, therefore nothing strange could have occurred. And they even said, hey, Venus is almost like the Earth and probably could support human life, and that the pressure wouldn't be really that big. But it turns out that the atmospheric pressure is like 1 kilometer deep in the ocean, and very few scuba divers go that deep. Also, they thought that Venus's magnetic field might be even stronger than that of the Earth, but it turns out that it's not even there. And they do have X-rays, but the magnetic field is not anywhere like the Earth. And Sagan supported the conventional idea, of course. And from 1962, Moore said that before that could have been vegetation on Venus and even primitive organic matters. And Sagan said in '63 that Venus could support life similar to that on Earth. But as you all know, it turned out that wasn't right. It's extremely hot. In fact, it's hot enough to melt lead. So the previous ideas of water-covered Venus weren't even close. They also thought that all of the planets formed about the same time in the same way, therefore they should all spin about the same direction. And here you see the list at the bottom that shows that what they thought they would find or even at that time what they knew. For example, they assumed that Venus had a spin and a tilt pretty similar to the Earth, and most of the rest weren't really that close. And this is the order that Don was talking about with respect to the Titius rule, and it turns out that even in the 60s and 70s, astronomers were saying that, well, the Titius rule worked so well that Venus could not have been a planet added later. Well, I did like Don and said, hey, you're talking a mnemonic here, you're just doing a curve fit. So I played around with the formula, and it turns out that if you change the 0.3 in the formula to 0.6, everything remains exactly the same except for the orbit of Venus completely disappears. So after that, I had no astronomers telling me that Bode's law meant anything. And here, like you see on the bottom, you expected Venus to have the same tilt and the same rotation rate of the Earth, but it turned out that it wasn't even close. Venus has almost 0-degree tilt, and it spins the wrong direction. So to explain why it spins the wrong direction, various people, mainly Singer, said that, well, there was a retrograde moon that collided with Venus and made it spin backward. Well, you've not only introduced collisions, but now you've just set the problem back to the retrograde moon people. You haven't really explained anything. And I'm not saying any of their calculations were correct, but it shows that people now are willing to consider probably something did change after the origin of the solar system. Generally, they'll tell you, except that was billions of years ago, except for the exceptions. And someone has shown a chart earlier that showed Venus in a comet-like appearance, that its magnetotail reaches all the way to Earth. And it turns out the ancients said that, hey, Venus used to look like a comet, and Venus and comets were gods. And so you wonder, gee, was there anything surprising about comets after 1950 when they said that that couldn't have happened because comets are too small, they are basically dusty, and they're basically icy snowballs. And in fact, of course, Sagan agreed with the standard theory at the time, being that it was icy snowballs. And these are quotations from his book that makes it clear what he thought. But it turns out that not everybody at the time thought that comets were icy snowballs. Some even admitted to the possibility of some magnetohydrodynamic models. Unfortunately, the Alfvén, who's been mentioned before, won the Nobel Prize in Plasma Science, and he was talking about, in general, if you have a theory that doesn't match what's accepted, it's probably going to be ignored, but that in particular, plasma theory of comets was ignored. And it turns out that it was decades before there was any change, although a couple of years after Alfvén said that, Rosen and Brandt said that about the comet Kohoutek, possible detection of colliding plasmoids in the tail of comet Kohoutek. So, but of course nobody ever heard about that. But at least they got that published. And it turns out that, of course, a lot of data doesn't support the dirty snowball theory. So they're now saying, hey, there's very difficult to tell the difference between an asteroid and a comet. Not only do you have odd things happening with comets with respect to not ice, but they've even found that they emit X-rays. And more recently, they have discovered that what they call solar wind charge exchange. So if you do a search on SWCX, you'll find that they're saying that the interaction of the solar wind with the comet phases or with places like Saturn, various atmospheres will create X-rays. And they, for years, noticed that comets appear to flare up overnight when they're too far from the sun to even be heated or have their ice heated and turned into gases. And of course, gee, we're not sure exactly what does that. And 50-50 chance here was flip a coin. Not that there was any statistical analysis done, but they were surprised that it was electrons close to the comet surface and not the photons as they had believed that created a lot of the comet activity. So you think, gee, if you're surprised almost every time you do anything to take data, maybe you should reconsider the theory. But of course, cold thinking dies kind of hard. And even last year, when the Rosetta encounter came, they expected to find the ice. But of course, they didn't. But data eventually wins, and so they started saying, hey, maybe it's time to stop thinking of comets as dirty snowballs. Of course, they don't, but they admit it's probably time to do that. Mars had its own problems, again, with reference to the 1950 time period. At that time, they thought it was going to be a cold, dead planet. And even by 1962, they knew that that wasn't right. And here you see what Moore in his 1962 book expected the Martian atmosphere to be composed of, and then what is probably one of the more recent expectations of the composition. Also, in 1950s and 60s, they said, hey, Mars is pretty smooth. There's not even any hills there. But then it turns out that Olympus Mons is higher than Mount Everest. And here they talk about a change in the climate may have occurred in the recent past. Again, they don't define recent, but they expect everybody to think of it as billions of years ago. Then the Cookie Monster on Mars has been a problem lately. They say they're unable to account for it. Now, it's always been known that Mars has two moons, but the problem is, according to Singer, they weren't able to explain the origin of the moons. And at this conference in 2003, they said, well, maybe the two moons are the result of a collision of something else than a bigger moon. And again, they're willing to say catastrophes occurred when they need them for what they want it for. But even worse, it's got two moons as we speak. But the implication is they may not be there that long. So you wonder, if they're willing to say this, how many moons did it have in the past, and how many collided with Mars or something else odd in the last 10,000 years? Moving beyond to Mars, we've seen all the things about the little odd shiny spots on Ceres, and they still say, well, we think we kind of know maybe what we might consider it to be, but we're not really sure yet. In Vesta, the nice thing about that is just the density and all that challenged the models of the formation of everything in the solar system. We'll get into details about some of that tomorrow. And you can't always tell, as we saw previously, what's a comet, what isn't. This guy tracked an asteroid for all of this time and then finally found out, hey, that's a comet. And they even hinted at a potential plasma link because of the kink. They call it a kink in the tail, but that's a plasma term. In Jupiter, again, in 1950, it was a cold, dead planet, and that it couldn't have any star-type characteristics. But then in 96, they say, hey, well, maybe it's got a star-like atmosphere. And again in 1950, they said, it's so cold. When suggestions were made to look for radio noise on Jupiter, because it fit with all of the catastrophe theories, they said, no, it's not even worth the trouble. And so a few years later, they accidentally found the radio noise emitted from Jupiter. Another unexpected, Jupiter's got rings. Not only that, got this dust going the wrong direction. And turns out it's going all different directions. Again, an oddity that is a plasma phenomena, but doesn't fit just standard basic gravity theory. And this one, surface radically different from anything in the solar system. That's odd. If everything fits the standard theory. Not only that, it interferes with the magnetic field of Jupiter. And of course, completely unexpected. And Ganymede had a magnetic field. Well, that sort of messes up their theory about why they thought things had magnetic fields. It shouldn't have a magnetic field, at least according to the accepted theory, it shouldn't. So it was a big surprise. And this is another satellite, and the density was a surprise because the theory about how the density changes as a function distance from the main planet is completely off because of this one. The F-ring of Saturn had all these loops and supposedly defied the laws of physics. Well, they defied the laws of gravitational only physics, not the laws of plasma physics. They also have a B ring around Saturn that had radial spokes, and this thing supposedly completely contradicted all traditional notions, all except if you consider the electrostatic field. Also, there were X-rays found from Saturn that were unexpected, mainly because they were like 50 times or so more than they should have been from just what they thought you would expect to get X-rays from reflection from the sun. They found also a old radiation belt around Saturn. Which of course came as a big surprise. Titan's atmosphere, they thought that would be very similar to Earth, and you could do all these experiments about early Earth. Then they got up there and found out that wasn't right at all. But they did find that Titan is like the Earth in that it has what they call a polar wind that shoots atmospheric material out into space. And that is like the polar wind on Earth that shoots atmospheric material out into space. If you call it a polar wind, people won't know that it's a plasma. So they just say, hey, the polar wind on Titan is like the polar wind on Earth, and not have to say anything misleading about plasma. Iapetus is odd in that it's got this ring around, pretty much halfway around the body of it. And of course it surprised everybody, but the latest thinking is that it was debris circling and then fell in, which I guess is fine if you're willing to go with catastrophes of that nature. Mimas is smooth, and they said, well, it's too smooth. There must have been craters there one time, and they got smoothed over. Well, how did that happen? I like this one. It, as far as I know, was not mentioned in 1950, but the nice thing about it is when their space probe went by it, it got electrons coming from Hyperion, and that fits in with some of the earlier discussions about electrons being on various bodies. Like this one again, the finding flipped everything scientists knew about Enceladus on its head. Pretty much everything was backward. And again, a core that contradicts everything we thought we knew about how planets formed. And again, we'll go into that in a little more detail tomorrow. Rhea has rings around it. It's moon of Saturn, and it's got its own rings, of course, which was a big surprise. I like this one too, that just an asteroid out there has its own rings, and they weren't looking for them, didn't expect them, had no idea that that kind of body would have rings. It was known in 1950 that Uranus had an odd axis, but then they found out that the magnetic field was skewed even more than the rotational axis. Not only that, it was hot at the wrong place. When they took measurements, the sun was pointed toward the pole of Saturn, and when they took the measurements, there was more heat coming from the equator of Saturn, from Uranus, than there was from the pole where the sun was heating it. And Neptune had a oddly rotated magnetic axis. Again, that just didn't seem to fit what they expected from the standard theory about how all of those the magnetic fields are generated. And it turns out that it emits twice as much energy as it receives from the sun. Obviously, not a cold, dead planet. And beyond Neptune, you've got all of these odd orbits. Unfortunately, the current theory doesn't fit any of it, pretty much. Pluto is now thought of, in some cases, as a double body with Chiron and Pluto kind of rotating around each other, and the various moons around it. And you can see in the picture that the center of the three large ones is darker than the other, and they didn't expect that. And just like with everything in 1950, we assumed they would all have been formed the same way. And so we're surprised that one of them's a lot darker than the other one. If you assume nothing happened, that doesn't mean nothing happened. And if the data doesn't fit your assumption, then maybe you should be thinking about something else. And it's nothing against the scientists of the time for making assumptions and checking data. That's just science. The thing is, after you check the data and it doesn't fit your theory, then you've got to start modifying your theory. And just because your original assumption was that there were no catastrophes and that mythology is pure fiction, the data doesn't seem to fit that, so maybe it's time to reconsider. In fact, a lot of people have reconsidered. These are people that have relatively recently written books describing a lot of what the ancient mythology said with respect to what you can show in the solar system. This gets in with what Tom was talking about earlier, but this is from the book The Opposable Mind, where he says you really need to have something that's just perfect and you can defend it, because he didn't say it this way, but basically you can then retire. Another reason for needing to accept the conventional wisdom is that if you want your degree, then you have to support the theory that your professor is supporting. And if you want to get a job somewhere, then you've got to support the kind of activity and the results that they expect. When they write a proposal to the government, they'll say, we will do this and this and this, and we will find this and this and this, and so you'd better do it. And it's not really a new problem. This is from 1804, but the experiment was done a little bit before that, and this is the typical reaction you get when you do something that's not within the mainstream. But, like I said, eventually science changes. For example, when the first rocks came back from the moon, the scientists said, no water on the moon. So it became absolutely true that you'd better not find water on those rocks in the moon, because we have spoken. It turns out that later they pretty much showed that, hey, there has been water on the moon. And the interesting thing is they admitted it shows a bias in the scientific community. So admitting it is part way to getting around to solving the problem. This is from Carl Sagan. You probably won't recognize this as the same Carl Sagan and mentioned previously, but this is quite good. Especially the part that history has shown that accepted and conventional ideas are often wrong, and that fundamental rights or insights can arise from the most unexpected sources. They need to read that again. Bertrand Russell was Picard, sorry, was the pilot of the first electric airplane. They said it couldn't be done. Thank you.